Hey everybody, it's Mr. Mott. What we're going to do is go through a few heat calculation problems, solving for Q and then solving for a few other things. Grab this worksheet from online, so let's go ahead and get started. Um, so number 8 says how much heat is required to warm 275 grams, that's a mass, so the units of grams, of water from 76 to 87. So I've labeled the initial temperature where it starts and the final temperature where it ends. And so we want to know heat, and so we're actually going to be solving for Q. So our formula is Q equals M times C times delta T. And so plugging in, I've got a mass of 275 grams. My specific heat, the C value, is coming from water in the liquid form, so it's our 4.18. 4.18, they go out to one more decimal than we do in class, and that's joules per gram degree Celsius. And then we have our final temperature, 87 degrees, minus our initial temperature, 76 degrees. All right. Calculating that out, my raw number for my calculator is 12644.5 joules. Rounding to significant figures, this value for the mass has 3, and then this value has 2, because when we were to subtract those, we would get 11 degrees. So that's 2. So I'm going to round my value now to 1, 3, and then 0, 0, 0 joules as my rounded answer with significant figures. All right. Number 9 here, asking a similar problem. It gives us some background information on PCl3. It gives us our mass because we have the grams here. And we have the initial temperature. And we have our final temperature as well, TF. And wants to know how much energy. And then it's given the specific heat value is here. So this is our C value. So again, our formula is Q equals M times C times delta T. Q equals the mass, which is 96.7 grams. The specific heat of this chemical is 0.874 joules per gram degree Celsius. The final temperature is 69.2 degrees. The initial temperature is 31.7 degrees. So let's go ahead and calculate that out. 96.7 times 0.874 times the quantity 69.2 minus 31.7. And my raw number is 3169 joules. And we're going to have 3 significant figures from this value here. When we subtract this value, we'd have 3 sig figs as well. So I would round this to 3170 joules with no decimal at the end. All right. So 8 and 9, our first 2 problems that we did, we're solving for Q. The next 2 problems are going to be solving for something other than that. So involve a little bit more algebra. Number 10 says the quantity of water is heated from 25 to 36.4, and it's absorbing 325 joules of energy, which is our Q, and wants to know the mass. So my formula is Q equals M times C times delta T. Whenever I'm whenever I'm solving for anything other than Q, I like to rearrange it to get that variable by itself. So I want mass by itself. Mass is being multiplied by C delta T. So we're going to divide by C delta T, which is going to have those 2 things cancel. So my new formula then, mass equals Q over C delta T. My Q value is given at 325 joules. My C value, this is for water, so that's going to be 4.184, which is the value on this worksheet. If you have 4.18, that's fine. And our delta T is our T final, 36.4 minus 25.0 as my change in temperature. So 325 divided by 4.184 divided by the quantity 36.4 minus 25, and we're getting around the mass is going to be 6.81. All right. And again, that's 3 sig figs from this value here. When we subtract this, we would get like 11.4. That's 3 sig figs as well. So that's our final answer. All right. Lastly, number 11 here, we have a mass, 500 gram sample of an unknown metal. This is our Q value because it has units of joules. It's going to cool, that's a really good clue, from, so that means this is our initial temperature, to our 25 degrees, our final temperature, and what is the specific heat. So our formula is, again, Q equals MC delta T. In this case, we're going to be solving for the specific heat, which is C. C is being multiplied by M and delta T. So to get C by itself, we divide by M delta T. All right, and then those cancel. So C equals Q over M delta T. And so we are now going to plug in our info. Since it's releasing, that means our Q is a negative value. So 6.4 times 10 to the second joules. The mass was given as 500 grams, 500 with a decimal grams. And my final temperature was 25.0 minus the initial temperature, 55.0. All right, so our C value is, let's go ahead and calculate, negative 6.4 times 10 to the second divided by 500 grams divided by the quantity 25 minus 55. And we're getting a value of 0.0426 repeating, so I'm going to go to 7. Actually, I'm going to go to, so if that was my raw value for joules per gram degree Celsius, I would then round that to 2 sig figs from this value here, the 6.4, even though this is 3 and this would be 3 significant figures. So I would actually round that to 0.043 joules per gram degree Celsius. All right. Hopefully that's helping you rearrange the heat formula as needed. A couple of pieces of advice you'll notice that I did: label everything as you go along. Write out your original formula. If you need to rearrange it into what you're solving for, so that when I have all my numbers, this is how I'm going to put it in my calculator. All right, thanks for watching.